Hello, everyone. I'm Zihan Wang, currently a master's student at the Institute of Computing Technology of the Chinese Academy of Science. Here I'm very glad to present our method grid memory map for vision and language navigation. In our method, we build the top-down egocentric and dynamically growing grid memory map to structure the visited environment. From a global perspective, historical observations are projected into a unified grid map in a top-down view, which can better represent the spatial relations of the environment. From a local perspective, we further propose an instruction relevance aggregation method to capture fine-grained visual clues in each grid region. In previous works, in order to achieve backtracking and make global planning, a few approaches structure the topological map. However, these methods are difficult to represent the spatial relations among objects and scenes in historical observations, thus a lot of detailed information is lost. And some methods use object-centric scene graph to represent the object relationships, which are not enough to represent all visual information, such as house structure and background. The top-down semantic map represents spatial relations more precisely, but the semantic space are extremely limited due to the predefined semantic labels. In contrast to previous approaches, we propose the grid memory map, a new visual representation structure for modeling global historical observations during navigation. Specifically, the grid map divides the visited environment into many equally large grid regions, and each grid region contains many fine-grained visual features. We dynamically construct a grid memory bank to update the grid map during navigation. At each step of navigation, the grid features from the pre-trained CLIP model are saved into the memory bank, and all of them are categorized into the grid map regions based on their coordinates calculated via the depth information. To obtain a holistic representation of each region, we design an instruction relevance aggregation method to capture the visual clues most relevant to navigation instructions. With the help of aggregated features in the grid map, the agent is able to accurately conduct the next action planning. Panoramic view features, map cell features, and trajectory features are fed into a two-stage cross-modal encoder for both local action prediction and global action planning. Next is our demo showcase. As you can see, our grid memory map expands with the expansion of the visited environment, which enables better long-term planning with global spatial perception. This page compares our approach with the previous VLN methods on the Reverie, R2R and Soon benchmarks. Our method outperforms many existing methods on mainstream benchmarks of discrete environments. In particular, our approach significantly outperforms all previous methods on the R2R CE dataset in Table 4, demonstrating the effectiveness of our method for VLN CE. We compare the performance of different maps representing the visited environments on the VAL unseen split of the R2R CE dataset. Results in Table 5 indicate that our method is superior to the topological and semantic maps. Next is the ablation study. The experiments have shown that the grid memory map, egocentric view, trajectory information, and the instruction relevance aggregation method all have benefits for navigation performance. And we observe an upward trend in navigation performance as the map scale increases. On this page, we will present some statistical analysis results. As illustrated in the left figure, the side length of grid memory map increases with the expansion of the visited environment. Obviously, the fixed-size map is difficult to adapt to the visited environment that constantly expands, thus our grid memory map with a dynamically relative coordinate system works better. As illustrated in the right figure, so many features within a cell region results in critical cues being overwhelmed by noise. So the instruction relevance aggregation method is needed to filter out irrelevant features and captures critical clues. That's all. Thanks for watching.